Hi, I'm Miss Hall, and this is Lesson 77, Modeling with Sine and Cosine Functions. We'll begin by looking at frequency. The periodic nature of trigonometric functions makes them useful for modeling oscillating motions or repeating patterns that occur in real life. Some examples are sound waves, the motion of a pendulum, and seasons of the year. In such applications, the reciprocal of the period is called the frequency, which gives the number of cycles per unit of time. In example 1, find the frequency of the function. Well, frequency is the reciprocal of the period. We know how to find the period. Period is 2 pi over the absolute value of b. In this case, it is 2 pi over 4 pi, which is 1/2. And if we look at this graph, because I've graphed it, this is 1. Here is 1/2. So one cycle of the pattern happens in 1/2 the horizontal distance. Yes. The frequency is the reciprocal of period. Frequency. So we can take the reciprocal, 2 over 1, or 2. And what this does is it gives the number of cycles per unit of time. If we assign the x a unit of time, let's call it seconds, then this frequency is how many cycles per second. So we can think of 2 cycles per second. You see here's the 1. And you can see that we have 2 complete cycles of the sine function in 1 second. So again, frequency, you can take the reciprocal of the period. And the meaning behind frequency is it gives the number of cycles per unit of time. Next up, writing trigonometric functions. Graphs of sine and cosine functions are called sinusoids. One method to write a sine or cosine function that models a sinusoid is to find the values of a, b, h, and k for either the sine or cosine function, where absolute value of a is the amplitude, 2 pi over b is the period as long as b is a positive value, h is the horizontal shift, and k is the vertical shift. Example 2, writing a trigonometric function. Write a function for the sinusoid shown. Okay, I am going to begin by finding the amplitude, because the amplitude is 1/2 the distance between the max minus min value. So the maximum y value is 5. The minimum y value is -1. Therefore, the amplitude of this function is 3. I have found the a value. This amplitude is going to help me identify the midline. So I'm going to go from 5 down 3 units. 1, 2, 3. And now I have the midline of this function. Right, where 3 units above is the maximum, 3 units below is the minimum. Let me double check. 1, 2, 3. 3 units below is the minimum. So this is my midline. If you remember, the midline is y equals k. And here the midline is 2. Y equals 2. So I found my k value. What am I missing? I'm missing the period. So I'm going to look for one complete cycle. This seems to be a sine function. I'm going to call it a sine function because it starts at the midline, and I know that sine. I've written it so many times that I know the sine of x starts at 0, goes to its maximum, goes to 0, goes to its minimum, goes to 0. That's one complete cycle on the unit circle, and this one has an amplitude of 3, so it's slightly different. But it goes up 0, down 0. Okay. So this is one period occurs at, that seems to be pi over 2. So I know that one period occurs in pi over 2 distance. So to find that b value, the period, remember, is 2 pi over b. And when I simplify this, I get pi over 2. So I can solve for b. I can cross multiply if I want, and I'll see that B equals 4. I've got A, I've got K, I've got B. H, a horizontal shift. There is no horizontal shift because I'm going to use the sine function. And the sine function starts, like I said, at 0 or the midline, goes to its maximum point, then back to 0, to its minimum point, then back to 0 or the midline. So my horizontal shift, or my H value, is going to be 0. I have all the information I need to write my function. We have y equals the amplitude 3. I'm using sine of 4x plus 2. And if I wanted to check it, I could put it in a graphing calculator to see that I get this graph.